Hello. So in this section, we're going to be looking at dividing polynomials. So again, last time we looked at algebraic fractions. As an example, x squared plus x minus 2 over, say, x plus 3. That is an algebraic fraction, or we call that a rational function or expression, because there's a polynomial on the top and the bottom, the numerator and the denominator of the fraction. And last time we looked at simplifying by finding common factors or common numbers or terms that are both on the top and the bottom, which we can then divide through, just like with normal fractions. And so we're going to look at then dividing polynomials. And actually we can see that with fractions, because really a fraction is just division, right? Because in general, a over b is exactly the same as saying a divided by b, right? And we're going to look at exactly how that works today in this video. Okay, so first of all, I'm going to do a bit of a GC recap and remind you that if we have a fraction, say 7 over 3, we call this an improper or a top-heavy heavy, there we are, fraction, because the number on the top, the numerator, is bigger than the bottom, hence the word top-heavy, okay? The top is kind of bigger, heavier than the bottom, and so when we don't like that, really, we want fractions to be bigger on the numerator, because it turns out if the number on the top is bigger, then we can simplify it down, okay? So we would have seen at GCSE how we can write that as a mixed number by utilising how many times 3 goes into 7. So as a brief reminder, 7 over 3 we can write as a mixed number as, for example, well, it'd be out of 3. No, sorry. Firstly, how many 3's go into 7? Well, it's 2, right? But then there's a remainder of 1, because 3, 6, and then you need, well, then you'd be going over if you then went to 9. So then 3, 6, and then you got 1 left over. So 2 whole bits of 3, and you got 1 left over. So you'd have 1 over 3 there to get to 7. Okay, and then another example, say we had 11 over 4. Right, again, that's top heavy. 11's bigger than 4. So then we could say, well, how many 4's go to 11? Well, 2. 4, 8, but then 12 would be bigger than 11. So we have 2 lots of 4. Then out of 4, well, to get from 8 to 11, we need 3. Okay. And so the whole idea is that we reduce the fraction down to be smaller. Okay, so now it's no longer top heavy. And so this reads as well 2 and a third. Okay, and in this example here, 2 and 3/4. So you can think of that as saying literally 2 plus 3 over 4, and that'd be the same fraction as 11 over 4, okay? And so this introduces the idea of a sort of remainder, and how many times things go into each other, right? Okay, so we see then that, like with GCSE, we can simplify fractions into top heavy, and that's exactly the same with algebraic terms. Except, how do we classify what it means to be top heavy? Well, it's when any algebraic fraction, again, as I remind you, when we looked at last time, which are polynomials on the top and the bottom. That's an algebraic fraction. And it's top heavy or improper when the polynomial, well, really, I guess in simple terms, the polynomial on the top is bigger than the polynomial on the bottom. But what does that mean? Really, like, getting down to it, what does that mean? Well, it means that the degree, right, of the polynomial, so degree of p of x the top polynomial, is at least the degree of the bottom one. Of q of x. Okay, so as a brief example, say, well, let's have a look at this example we did at the start right here. This is a top-heavy fraction because we have x squared as the highest power to 2. The highest power here is 1. Okay, so 2 is bigger than 1. So that means it's top-heavy, and we will be able to divide, right, simplify it. But we'll look at that in just a moment. Another example, say we have x cubed minus 1 over x squared plus x plus 5. That is top heavy because there we have x cubed over x squared. So 3 is bigger than 1. Well, 3 is bigger than 2, so that means we can. It's a top heavy fraction. Another example is x squared plus 2 over x squared minus x minus 1. Well, this is also top heavy because although the powers on the top and the bottom, 2 and 2, x squared and x squared, they're the same. Well, that's still top heavy because it can be equal. Okay, if the degrees are still the same, it will still be top heavy. Okay. And then as another example, so I'll say this is top heavy. This is top heavy. And then as another example, then if we had, say, x squared plus 1 over x cubed minus 1. Well, this is not top heavy because now the degree on the bottom is bigger than the top, so the top is not as heavy, shall we say. So this is not top heavy. Okay, cool. Okay. So in the case of top heavy fractions then, we can then do some what we call polynomial division to kind of cancel it down to then get a fraction that is no longer top heavy, right? Very, very, very similar to the idea that we saw here with numbers, right? We had a top heavy fraction there, 7 over 3. We reduced it down to a non-top heavy fraction there, which is a lot easier to work with. And so that's what we'll be doing, right? The sort of same idea of reducing down these fractions to non-top heavy ones, okay? And that's where algebraic division comes in. Okay, so final thing then before we look into an example, it might seem a bit wordy at the moment, but when we go through examples, it will start to make sense. I'm going to talk about something called the division theorem, which isn't explicitly mentioned in the spec of the textbook, but it's kind of, it's not explicitly stated, but they kind of do reference it at certain points, and it's really helpful to know anyway, in my opinion. But the division theorem then says that, well, if we have if we have a function f of x, and I'm assuming that all polynomials again, we're doing polynomial division, so everything's polynomials here. F of x, g of x, the functions I'm referencing. So if we have a function f of x, which is polynomial, we can then, if we say we divide it by a linear term, x minus a, say, but I'm going to leave it as fx for now. Well, we can break down any polynomial to say x minus a linear part, and then another function g of x, add a remainder there, okay? There, okay? And you'll see how that makes sense in a minute. What we call this then is we are divided by, then we can divide by x minus a to both sides. And you'll see more clearly why this, what this means. If we divide by x minus a to both sides, f of x over x minus a will then give us g of x, and then plus remainder over x minus a, okay? Right, so, Okay, so then this what we can say, this division, this fraction, this division, then if we then times it the other way around, we have any polynomial f of x can be written as x minus a times by this g of x, which is just another polynomial, add a remainder term, uh, which is kind of what we've got left over, right? Um, and so what the division theorem says is that we could write any polynomial in this way, okay? And we will be seeing that because this is essentially how polynomial division is works. That's what this gives us, right? As we go through the examples, I'm not going to talk too much more into that. As we go through examples, you'll see clearly what this all means. But I'm going to leave it there for now. Let's have a look at an example then. Okay, so we want to divide x cubed plus 2x squared minus 17x plus 6 by x minus 3. Right. In other words, this is saying x cubed plus 2x squared minus 17x plus 6 over x minus 3. Okay, it's very we kind of set it up in a very similar style to how we do division for normal numbers. So if we kind of use like a bus stop, well, outside of it is this divisor x minus 3, and then inside sort of the bus stop here we have the thing we're interested in, that on the top, x cubed plus 2x squared minus 17x plus 6. Okay, that's how we lay it out. Okay, if we have a fraction like this where we're dividing a polynomial on the top by the bit on the bottom, that's how we lay it out in this sort of bus stop sort of notation, if you will. No, not notation, but the way we express it in that way. So what we're dividing by, which we call the divisor, is on the outside, and what we have on the top here of the fraction, what we're dividing, what is it we're dividing to, is in the bottom. Is inside there. Okay. Right. So that's how we lay it out. Now, how do we go about dividing then? So, what we're going to want to do first is what we want to do is always consider the highest power throughout the process. So the highest power at the start of this is x cubed. That's what we're going to work with then. Okay, that's what we're always going to start off with, is the highest power. So we have x cubed. What we're then going to want to do is then divide by the highest power in outside. Okay, so then we have x. So what I want to do then is x cubed divided by x, and that is very simply x squared. Okay, so then I'm going to put that there. Okay, and it's going to match the x squared column. Okay, I'll call it the x squared column, right, as it matches the x squared term there. So I'm going to put that up the bus stop. Okay, and that eventually is going to give me what we call a quotient. Okay, so again, to remind, we got that from dividing the highest power inside, which was x cubed, by the highest power, or the highest term outside, which was x. Okay, then what we're going to want to do once we've got that part is we are then going to want to times this, what we have here, times that term x squared by every term here on the outside. So then I'm going to want x squared then times x firstly, and then I'm going to, that be x cubed, right? X squared times x is x cubed. So then I'm going to write that down here. Okay, and then I'm going to do the same for the minus 3. So then x squared times minus 3 will be minus 3x squared. So I'm going to write that down here. Again, it kind of matches the all the terms, the x squared terms are kind of on the same column, right? So we're lining them up. Okay. Once we've got that then, and hopefully what you should get is that the highest power term will be matching, and that will be important to us, because what we're going to do now is I want to get rid of the x cubed terms. Kind of think of these as sort of simultaneous equations. How do I want to get rid of x cubed? I'm going to take away the equations, right? So if I do that, then if I take away the top part, the x cubed plus 2x squared, by x cubed minus 3x squared, so then x cubed, firstly, x cubed take away x cubed will then be 0, x cubed. Then I'm going to get 2x squared take away minus 3x squared. That will be a double negative, so it'll be 2x squared plus 3x squared to get 5x squared. There, okay. There we are. Okay, so that's sort of the step, right? That's what we're going to be doing repeatedly until we get to no more, right? Until we get to we've used up all the numbers, right? We've completed the bus stop. But that's what we're going to be doing then. So what we're going to then do to then start off the next sort of part of this, to repeat the step, we're going to then bring down the next term here, which is minus 17x. I'm going to then bring that down there, and then I'm going to use it down here, okay? And then we literally then just repeat the step, repeat the method, right? So what we're going to then do then is then, well, the highest power now, you should always have a 0 at that point there. So then the new highest term will be 5x squared, okay? So then what I'm going to do then is 5x squared divided by the highest power here again, which would be x. 5x squared divided by x, that will be 5x, okay? And then I'm going to write that up there. And again, it matches the x column now there, so that lines up. Then I'm going to do then 5x times x, 5x times f in here. Again, so 5x times x first, it's 5x squared. And again, we do that specifically to match the two terms together, because you can see it's 5x squared on both lines, right? Which will allow me to take them away. Anyway, we get 5x times x is 5x squared. Then 5x times minus 3 would be minus 15x. And then what we're going to do then, we're going to take them away, right? And so then 5x squared take away 5x squared will get me 0, because that's what I want. I want 0x squared now. And then I have minus 17x take away minus 15x. Well, that would be a double negative, so it'd be minus 17 add 15x, that'd be minus 2x there, okay? And then I want to bring down the next number down here then. There we are. And so I have minus 2x add 6, okay? Right, and then I'm going to do the same thing again. Well, then the new highest term here is now minus 2x, because the x squared's gone away, it's 0. There we are. So minus 2x then, divided by the highest power outside, will be x. So minus 2x divided by x will be minus 2. And then I'll write that there to match the constants, or the numbers column at the end there. And so then I'm going to do the same then. So now I have minus 2. Minus 2 times x then will be minus 2x. Again, that's great news because they're matching. They're equal. And then minus 2 times minus 3 would then be plus 6 there, okay? And then I'm going to take the both equations, top and bottom, together. So minus 2x minus minus 2x, that'd be minus 2x add 2x, which should be 0. X. And then 6 take away 6 will then be 0 as well. So overall, I'm then left with 0. And I can't do anything more because there's no more numbers to bring down, okay? So that's it. That's the method done. So there we are then. So then you notice at the end of this, I will have two sort of different numbers. It's this quadratic term up there, and have this 0 at the end here, okay? We call, well, this is the main part we want, and we call that the quotient, and the part left over will be the remainder there, okay? And so then what that means is that this overall fraction, x cubed plus 2x squared minus 17x plus 6 over x minus 3, this division, right? Remember the fraction is division. Well, it's the quotient, x squared plus 5x minus 2, add a remainder of 0, okay? So it'd be add 0, and the remainder is out of the x minus 3, okay? So it'd be 0 over x minus 3. Well, actually, that goes to 0. So overall, this whole division, this fraction, just goes to x squared plus 5x minus 2. There we are. So that is what this division is doing. It breaks down a polynomial fraction in this way. And this whole fraction then is equivalent to x squared plus 5x minus 2, which is a lot more simpler to work with, okay? There we are. Okay. Let's have a look at another example then. So we have f of x is 4x to the 4 minus 17x squared plus 4. Divide f of x by 2x plus 1, giving your answer in this form here. Okay, so firstly, we're dividing 4x to the 4 minus 17x squared plus 4 all over this term here, 2x plus 1. So again, we're going to construct our bus stop. So firstly, the divisor, what we're divising by, has to be outside, and what we have on the top here, the 4x to the 4, blah blah blah, has to be inside. So 4x to the 4. Now, you would then perhaps be inclined to say minus 17x squared. However, there's no x cubed terms. It is very, very, very helpful actually to include all the terms, even if there's 0. Okay, so there's no x cubed term, which means we can actually write this as 0x cubed, right? And then we say minus 17x squared, and then there's no x term either, so we can say it's plus 0x plus a 4, okay? That allows us to then follow the same procedure without any hiccups, right? It allows us to smoothly do the same method if I just include all the powers of x, even if there's 0, okay? But there we are, that's how we set it up. Again then, so then I want to pick the highest part first. So that's 4x to the 4 inside. Then I want to divide up by 2, the highest power outside the bus stop, which is 2x. So 4x to the 4 divided by 2x. Well, that's simply 2x cubed, okay? So then I'll put it in the x cubed column up here, 2x cubed, okay? Then, what I'm then going to do is then times this 2x cubed by every term outside. So then that will get me 4x to the 4, right? And then 2x cubed times 1 is just 2x cubed. So add 2x cubed, okay? There we are. So then, I'm then going to take away these two sort of equations, right? Together. So then 4x to the 4, take away 4x to the 4, firstly. There. That'd be 0, right? 0x to the 4, which is just 0. Then I have 0x cubed, take away 2x cubed, well that would just be minus 2x cubed. There we are, okay. But then I need to then include the next term, so minus 17x squared, so I'm going to bring that down there, and then we'll repeat the same thing. So then what's the new highest power? Well, it's just a minus 2x cubed. So then I need to do minus 2x cubed divided by the highest power, 2x here. And so that'll be minus x squared. So then I write minus x squared there in the x squared column there. Okay, well then again I need to times this thing by every term outside. So minus x squared times 2x, well that's going to be minus 2x cubed again. Then I have cubed, sorry, and then minus x squared times 1 is just minus x squared again. And then I'm going to take away the equations, okay? So then I have minus 2x cubed, take away minus 2x cubed, that'd be, again, a double negative. So then minus 2x cubed add 2x cubed would then be 0 there. Then I have minus 17x squared, take away minus x squared, so that'd be minus 17x squared, add x squared, double negative again, that'd be minus 16x squared there. Cool, and then we need to again bring this next term here, plus 0x. And then we repeat the same thing. So then what's the highest power here in this bottom row here? Well, it's minus 16x squared. So then I need to divide that highest power, that highest term, by the highest power again, which is 2x. So divide by 2x. That'll be minus 8x, right? Minus 8x. There we are. So then I write minus 8x up here. And then I do the same thing. So I have minus 8x, then times by all the terms outside the bus stop. So minus 8x times 2x will be minus 16x squared again. And then minus 8x times 1 will be minus 8x. And that's a 0x. There we are. And then the same thing. I want to take away the these two equations, right? In between the lines there. So then minus 16x squared take away minus 16x squared would be adding 16. So that'd be 0 overall. Again. So just write that as 0. 0x squared there, and then 0x minus 8x, that'd be 0x add 8x, that'd be plus 8x there. And again, I need to bring that number down, so then plus 4. Cool. So then again, the highest term now is 8x. So then 8x, and then I need to divide 8x by, again, highest term outside, which will be 2x again. So then that would be simply 4. Okay, so then I add 4 there. And then 8x, then I need to then times the 4, sorry, by, again, all the terms outside the bus stop. So then 4 times 2x will be then plus 8x. And then 4 times 1 is just plus 4. And then if I take them away, then 8x take away to 8x is 0, and 4 take away 4 is 0. So I'm simply left with just 0 at the end there. And there we are. So there's nothing more to bring down, so we're done. Okay. And there we are. So again then, so if we then copy down our beginning fraction, right, which again is just a division, 4x to the 4 take away 17x squared plus 4 over 2x plus 1. Well again, now this is our quotient part. So from this I get 2x cubed minus x squared minus 8x plus 4. And the remainder term I get is plus 0. There, that's the remainder part. 0 over our divisor over 2x plus 1, sorry. But that just goes to 0. So simply that's all I'm left with there, is this cubic term there. Cool. So there we are then. So that's what this fraction simplifies to, is that. But then it's asked us to give it in this form. F of x is this. But f of x is actually just the quartic part. So to get f of x on its own, and then if I go back down here, this quartic part is f of x on the top. To get it on its own, I could just times both sides by 2x plus 1. Therefore, 4x to the 4 minus 17x squared plus 4 is 2x minus 1 times our cubic, right? And there we are. So that's the alternative way of writing it. And actually now it's in this form here, okay? And the coefficients a, b, c, d, they would correspond to a's 2, b's minus 1, c's minus 8, and d's 4. And that is a minus 8 there. There we are, my handwriting. But there we are, okay? So that's, again, just division, right? The same sort of idea. Of finding the highest powers and then going on from there, right? But there we are. Okay, example 4 then. We have a different question. We are asked to find the remainder when 2x to 2x cubed minus 5x squared minus 16x plus 10 is divided by this. So again, we need to consider the division. 2x to the 3 minus 5x squared minus 16x at 10 divided by x minus 4. So we need to then again do our bus stop. So the x minus 4, what we're dividing by, is outside, and what's inside is 2x cubed minus 5x squared minus 16x plus 10. Okay, I made that a bit neater. Okay, I'll take it. Right. So again, the method's going to be the same. So firstly, then we need to spot the highest term inside. That's 2x cubed. Then I want to do 2x cubed divided by the highest power outside the bus stop, which is x. Okay, so that divided by x is simply 2x squared. So then I put 2x squared up there on the x squared column. There we are. Then again, I want to then times this by all the terms outside the bus stop. So 2x squared times x will be 2x cubed. And then 2x squared times minus 4 will be minus 8x squared. And so again, I want to take away the top two equations in the bus stop. So then 2x cubed take away 2x cubed will be 0, which is what we want. Then we have minus 5x squared take away minus 8x squared there. So then that's minus 5x squared add 8x squared, that'd be plus 3x squared there. Okay. And then I'm going to bring the next number down to get minus 16x. And so there. So then we're going to repeat it again. So now the next highest term in here is 3x squared. And then so 3x squared divided by the x there is then 3x. Okay, so then we're going to write plus 3x up there. And that's what we're going to be using to times it by everything outside. Because then we're going to get 3x squared again. And then 3x times minus 4 is minus 12x. And then if we take those away, these two equations, by 3x squared minus 3x squared is 0. Again, what we want. Then minus 16x take away minus 12x. Again, that's we add, double negative. Minus 16x add 12x, and then be minus 4x. And there we are. So then we can bring this last number down here, which is a 10. There. And then the highest term now is minus 4x. So then minus 4x divided by the x. There, because again, x is the highest term out of x minus 4. So then that would be minus 4. Right. So then minus 4 times x firstly will then be minus 4x. And minus 4 times minus 4 will be plus 16. There we are. And again, we're going to take away both equations. And so we get minus 4x minus 4x will then be 0x. And then 10 take away 16 will be minus 6. And there's nothing more to bring down, nothing else, so that's it. So our remainder will be minus 6, because 0x is just 0. So minus 6 is now our remainder, and the quotient is 2x squared plus 3x minus 4. What that means is then, well, the remainder is minus 6 then, right? Because that's what the question said. The remainder is minus 6. But we can also then say the fraction is, again, if we repeat the fraction, 2x cubed minus 5x squared minus 16x plus 10 over x minus 4, was it? What these quotients and remainders mean is that this gives us firstly the quotient of 2x squared there, 2x squared plus 3x minus 4, and a remainder of minus 6 but it's a remainder, right? So minus 6 left over from x minus 4. Okay, and there we are. And we could just say it's minus 6. So there we are. So that's what that simplifies down to. Obviously, you might think, well, to simplify it, let's just combine it as one fraction. If you do that and do 2x squared plus 3x minus 4, take away all this and combine it as one fraction, you would actually just get this back. Okay, so nothing special there. But the whole idea is that it breaks it down into smaller powers of x. So it's kind of smaller, right? And it goes back to what we discussed earlier, is that this is a top-heavy fraction there, because x cubed, the highest power, is bigger than the highest power of x on the bottom. And so we simplified it down to here, because now this is not a top-heavy fraction. And when you go to A2, year 13, you will see it is very, very useful to do certain stuff like integration, and stuff like that, to be able to break down fractions into smaller components like this. But yeah, and so if we go back then to if you just go back to what we talked about in the start again, about this whole division theorem. I said, oh, that's not the start. Here, division theorem, of how we express a function or polynomial f of x. F of x in this way, where we have this linear part x minus a times by another polynomial g of x. Well, that turns out to be the quotient, right? That's the polynomial you get at the top of the bus stop, right? There. And then the remainder is obviously the number we get then at the bottom of everything there. So hopefully that starts to put it puts pen to paper what this actually means, right? Rather than just being this abstract theoretical thing. You've now seen what the quotient and the remainder is when you perform the division, right? And so actually this tells us a way to link it. And then if we then divided by the x minus a, then we get the quotient g of x again, which again be another polynomial, and then the remainder term, the number remainder, over the original x minus a, okay, which was the original what we're dividing by, okay. And again, you can see that here. So we had, for example, if f of x was x cubed plus 2x squared minus 17x plus 6, and then we're dividing it by x minus 3 here, eventually we then saw that this equals x squared plus 5x minus 2, and then the remainder of 0, okay, over the x minus 3. So that would be the remainder part again, but actually it turns out the remainder is 0, okay, and then this is the quotient part again, okay. And so that's what this is doing. This division is finding the quotient and the remainder to break down a division, right, in this way. And so what we get out of this method is what is summarised in this division theorem here. Again, you don't really need to memorise it. They're not expected to know this, but I think it's very helpful because this is basically what's underpinning. This is why we are doing this division, to be able to find a quotient and a remainder, to break down a particular polynomial in this way, to do a division in this way, and that's what this result is encapsulating, right? What we are doing with this method is basically summarised in this sort of statement, this equation, right, which we call the division theorem. Okay, and there we are. So another example then with that in mind. So as a reminder, let's go down here again. So look, this example we looked at, again, as a reminder, the division theorem is saying for any polynomial f of x divided by a linear factor x minus a, here it's x minus 4, then we have a quotient g of x, I should probably call it q of x to be honest, add a remainder term, or remainder number in this case, and we can see that here. If we then divided by x minus 4 in this case, f of x over x minus 4, we then get the quotient q of x, because dividing that by x minus 4, if I do x minus 4 there, it'll just get rid of that, and you're just left with the q of x, the quotient function, and then the remainder number over x minus 4. But that's what we got. We got the quotient here, which was q of x, and then the remainder of minus 6 over x minus 4. Okay, and so that is basically what the division theorem is, even though it looks a bit abstract. It looks a bit maybe a bit weird when you see it for the first time, but yeah, that's basically it then. And as another reminder, we only do this division when we have top heavy algebraic fractions, which again means the highest degree on the top and highest degree on the bottom, well, the degree on the top is at least as big as on the bottom. So here x cubed, again the x cubed, the highest term, is bigger than x squared, so it's top heavy, as again, which allowed us to then conduct division. And we can see that here, because for example here, x cubed is bigger than x in terms of powers, and 4x to the 4 here is bigger than 2x, x to the 4 is bigger than x. We have x cubed divided by x. So in all these cases, that allows us to do polynomial division in this way, to break down the fraction into a quotient part and a remainder part, okay, which simplifies our function. Okay, so I'm going to stop blabbering on about the theory. Let's look into some more examples to really hone in on how this method works. You only need to know how to perform it, right, to do the bus stop thing. All the other stuff about division theorem, you don't really need to know. But anyway, let's have a look at this. We are told to divide x cubed minus 1 by x minus 1. Let's write this out then as a fraction, because then this is saying x cubed minus 1 divided by x minus 1. And so again, the divisor, I then write outside the bus stop, and then I have x cubed minus 1 inside. But again, I have x cubed. If I then said minus 1, but then I need to incorporate the x squared and the x terms. Well, there are no such terms, so we could just call it 0x squared at 0x minus 1. And so we can then proceed with the method as usual. So then again, the highest power is x cubed. So then I need to do x cubed divided by the highest power outside the bracket, which is x, and that would be x squared. So then I have x squared up here. Then I do x squared here times by all the terms here. So x squared times x is x cubed again, and x squared times minus 1 is minus x squared. There we are. Then if I subtract both top and bottom, x cubed times minus x cubed will be 0. And then 0x squared, take away minus x squared, that's a double negative. That'd be plus 1 x squared, or just plus x squared. There. Then we need to bring this part down, then plus 0x. And so then then the highest power we have is x squared. The highest term x squared here. So then I need to do x squared divided by the highest power outside, which again is x, and that would be x, right? X squared divided by x is x. So then I need to then write plus x up here. So then again I times this by all the terms outside. The stop, so then that's x times x is x squared again, and then x times minus 1 being minus x. Again, then I need to subtract both equations, if you will. Not equations, but both top and bottom, right? To then get x squared, take away x squared is 0 again. And then 0x, take away minus x again, double negative. That'd be plus x there. And then I need to bring this number down, minus 1. And again, then, the highest power now is x. So then I need to then... so then I need to do x and divided by the highest power here, which is again x, and that'd be 1. So I need to put plus 1 there. So then I'll do this plus 1 times by all the terms again outside the bus stop. So 1 times x is x, and 1 times minus 1 is minus 1. There we are. So then if I then subtract both top and bottom again, x minus x will indeed be 0x or 0, and minus 1 and minus 1, that's minus 1 add 1, also gets me 0. So overall then, that's the end of it, nothing more to bring down. So my remainder is 0, so I'm done. So then, therefore, I can write this division. This fraction, again, it also represents a division, as our quotient, firstly. And then our remainder term of 0 over x minus 1. So we have 0 left over from x minus 1. But that's just 0, right? So that'd be just nothing. So there we are. So that is what we're left with, is this. So we purely just get a quotient there. So there we are. Let's have a look at this question then. We are given that f of x is 2x cubed plus 3x squared minus 8x plus 3. Firstly, we need to show then that f of x is equal to 2x minus 1, and then this sort of quadratic bracket, right? We need to find the missing numbers. Okay, okay, but how does this relate to division? Well, this is saying that 2x cubed plus 3x, if we substitute f of x in here, so minus 8x plus 3, this is saying it's 2x minus 1 of ax squared and bx plus c. Now you could perhaps expand the brackets, right, and then you could kind of perhaps compare coefficients. But actually instead, if I just want to find this factor alone, I can then just divide both parts by 2x minus 1. So therefore 2x cubed plus 3x squared minus 8x plus 3 over 2x minus 1, that will get me ax squared plus bx plus c, right? But this, then, this fraction is just a division. I'm dividing f of x, the cubic, on top by 2x minus 1. I know how to do that, right? I know how to do it using that bus stop method. So then let's write out the bus stop method to do the division. So then I have 2x minus 1 on the outside. And then I do my bus stop, and then I write my top part inside. So 2x cubed plus 3x squared minus 8x plus 3. And so again then, the highest term is 2x cubed there. So then 2x cubed divided by the highest term outside, the bus stop with 2x. Divided by 2x, I get x squared, okay? So that'd be plus x squared. So then x squared then times by everything outside the bus stop. So x squared times 2x is plus 2x cubed. And x squared times minus 1 is minus x squared. So then I'm going to subtract the top and the bottom parts. Again, so 2x cubed, take away 2x cubed will then be 0. X cubed is just 0. And then 3x squared, take away minus x squared, that'd be plus x squared. So that'd be 4x squared there. And then I need to bring this down, so then I get minus 8x there. And so then my new highest term is now 4x squared. So then I need to divide that by the highest term outside, which is 2x. And that will get me 2x. Okay, 4x squared divided by 2x is 2x. So then I get plus 2x there. And so then I need to times this 2x by every term outside the bus stop again. So then I get then I get 2x times 2x is plus 4x squared again. And 2x times minus 1 is minus 2x. And again, I then need to subtract the top and the bottom. So 4x squared take away 4x squared gets us 0. So then minus 8x take away minus 2x. That's minus 8x add 2x. That'd be minus 6x. Cool. And then we need to bring this 3 down there. So we need to then add the 3. Add the 3. And so then my new highest term is minus 6x, right? The highest power is x, so minus 6x divided by the highest power here, highest term 2x. So then that'd be minus 3 on its own. There we are. So then I need to do minus 3 times f in outside. So minus 3 times 2x is minus 6x. And minus 3 times minus 1 is plus 3. And so then if I take away the top and the bottom, that's minus 6x minus minus 6x. So add it, you get 0. X. And then 3 take away 3 is 0 again. So overall 0, 0, I get 0. And that is my remainder. Okay. Therefore, my 2x cubed plus 3x squared minus 8x over 3 over 2x minus 1 gets me the quotient part, 2x x squared plus 2x minus 3, and then there's a remainder of 0, so I don't add anything on, there's no remainder. So it's purely x squared at 2x minus 3. Well, there we are then, because we said that this equals this quadratic part. So therefore then we could say f of x then, because we know this ax squared plus bx plus c, it's this, right? It's this quadratic term here. So therefore then, if we then times across by 2x minus 1, I get f of x, but no, I'll just say it's 2x cubed plus 3x squared minus 8x plus 3, which is f of x, and then that'd be 2x minus 1, and then x squared plus 2x minus 3. There we are. Cool. That's part A. Then part B says, hence factorise f of x completely. Well, what else can be factorised here? Well, not the 2x minus 1, but this is a quadratic. I should be able to factorise that. So then I need to then consider the factors. No, sorry. So I have 2x squared plus 2x minus 3. I want to factorise that. So in order to do that then, remember we looked at factorising quadratics before in the course. So then I need to consider two numbers that multiply to get minus 3 and add to get 2. So then, well, the only factors are 3 and 1. And I notice then, those are my factors, because 3 take away 1 will get me 2. But then I need to account for the negative. So I have negative 3. So that means if I want two numbers that multiply to get negative 3, well, I want to make both my... so I want one of these numbers to be negative, but I need to add them to get 2. It needs to be positive. So I need to make minus 1 the negative. So then 3 times minus 1 would be minus 3, and 3 take away 1 would be 2. So those are my factors. So there we are then. So therefore we can factorise it even further to then say that 2x cubed plus 3x squared minus 8x plus 3 is indeed the 2x minus 1 there. And this quadratic part factorised even further to x plus 3, x minus 1. There we are. Cool. Then part C says, write down all the real roots to the equation. F of x is 0. Well, f of x then, again, is that those factors, right? So if f of x is 0, which is this cubic, right? Well, then that means that this whole thing has to equal 0. So 2x minus 1, x plus 3, x minus 1 equals 0. Well, then there we are then. So again, these are 3 brackets, 3 factors. I remember we can solve this by setting each bracket or factor to 0. So therefore 2x minus 1 equals 0, or x plus 3 equals 0, or x minus 1 equals 0. So then therefore then if we solve each of these, x would then be either half or minus 3 or 1. And those are my roots. There we are. Cool. So there we are then. So yeah, it is helpful then to see how we can, that is an example how dividing fractions does help, because in this example we can then find the roots to a particular equation. Okay, so hopefully you start to get a gist of the method now. I do advise, with all my videos actually, but especially with this one, to practice it and do some questions yourself, or perhaps retrying a question I did earlier, but then pausing it and do it yourself, and hopefully you get the same answer I did there. But I think this is one of the things you just need to practice to get a hang of. But hopefully you kind of get an idea of how to do division now after I've done some examples. But we're going to jump into some exam questions then to finish off. So firstly, we're given a function f, which is defined by this. And we firstly then need to show that, well, not firstly, but we just need to show that f of x can be written as this, right? So effectively, this is saying 8x plus 5 over 2x plus 3, which is f of x, again, remember, can also be written in this form, a plus b over 2x plus 3. Now, I can't simplify this fraction in the obvious way by trying to think of factors to cancel out, because it doesn't factorize. So what else can I do? Well, I can divide it, right? If I can't do anything else, I can just literally divide the fraction, right? I can do polynomial division, because this is saying 8x plus 5 divided by 2x plus 3. And I know I should be doing polynomial division. Why? Because I discussed earlier, this is a top-heavy fraction, which means I am, and I probably should be, dividing through the or dividing the fraction in order to break it down. Okay. So really, whenever you see top-heavy fraction, if you can't simplify it any other way, you should think division, because the division, the whole idea is to break it down, as we saw earlier. And we can do that here again because 8x and 2x, well, the powers of x, the highest powers, are 1, right? They're both linear, but they're both equal. Okay, remember, as we saw at the start with these 3 examples here. This one, for instance, even though the power on the top and the bottom is x squared, that's still top heavy because it can be, even if the polynomials have equal degree, that's still top heavy. The only time it isn't a top heavy fraction is if the power on the top is strictly less than the power on the bottom. Okay, so in this case it's not top heavy because x squared is less than x cubed. However, in this case, the highest powers here are indeed x and x, right? So that is a top-heavy fraction, so we can do division. Anyway, let's get on with that then. So, well, this is a division, right? So I can go ahead with that. So I have 2x plus 3 on the outside, the bus stop, and then I have the 8x plus 5 inside. So again, I'm gonna do my normal method, where again the highest power inside the bus stop is 8x. So then I need to do 8x, the highest power inside, divided by the highest term outside, which is 2x. And that'll just be 4. So I can then add 4 there to get 4. Then with this 4, I need to then times by everything outside. Outside the bus stop. So then 4 times 2x is indeed 8x. And 4 times 3 is plus 12. And so if I take them away, 8x take away 8x is 0. And 5 take away 12 is 5 minus 12, which is minus 7 there. And I can't bring anything down. That's it. That's quite a short one, actually. There we are. That's it, right? So the remainder is minus 7 then. And our quotient is 4, which means that we can write our fraction as then firstly the quotient, the number on the top, well, it's just 4. Add a remainder of minus 7, and so you have minus 7 left over from 2x plus 3. There we are. And there we are. So actually then, if you match it with this form, well, therefore A has to be 4, and B, which is our remainder, is minus 7. There we are. There we are then. Cool. Final exam question then. We are given that x squared plus 8x minus 3 over x plus 2 is triple lines, which means identical to 8ax plus b plus c over x plus 2. Where this means identical, it means it's true for every single value of x. So it's not an equation where we're solving for particular values of x. An identity is a statement that's true for every value of x whatsoever. So it's not really solving anything. They're just identical to one another. Anyway, so again, we can't really simplify this fraction down. I mean, you could try and factorise this, but I don't think you'll get any common factors with the bottom of x plus 2. And we can see that here because it's quite an awkward sort of expression on the end there, which makes me to believe it's a quotient or remainder. So it makes me believe that this will be the quotient part and that will be the remainder number. I get the C. So that again, and because it's a top heavy fraction again, because x squared is bigger than x, the highest powers, it's a top heavy fraction, which leads me to believe I should be performing algebraic division or polynomial division, and that's what we're going to do. So again, this whole fraction, what we got is a division. So we're dividing the quadratic by x plus 2. So let's do x plus 2 our divisor outside and then our quadratic inside. And so again, the highest term is x squared. I'm going to then do x squared divided by the highest term outside, which is x. And simply that's x. So now I'm going to write x up here. And so then I'm going to times x by everything outside. So then that's going to be x times x, which is x squared, firstly. And then x times 2 is plus 2x. So then I'm going to take them away. And so x squared take away x squared is 0x squared. And then 8x take away 2x is plus 6x. Then I'm going to bring that minus 3 down here. And so then the same method is then the highest term I've got now is 6x. So then I'm going to then do 6x, the highest power I've got inside, by the highest power outside, which is then x again, which will then be 6. So plus 6 up there. And so then I do this plus 6 times everything outside. So then 6 times x is 6x firstly, and 6 times 2 is plus 12 there. And again then I need to take them away. To get 6x take away 6x is 0x, and minus 3 minus 12 is minus 15. So overall my remainder there is minus 15, and I get a quotient of x plus 6. Therefore then that tells me my fraction, which was x squared plus 8x minus 3 over x plus 2, well, it gets me the quotient part of x plus 6. And the remainder that I've got left over from x plus 2, minus 15 over x plus 2. There. And so if we compare it with the form they wanted us to give it in, here, ax plus b, well, this is x plus 6, so clearly a would be 1, b would be positive 6. And then it also plus c, a number c, over x plus 2. Well, here I have minus 15 over x plus 2. So c would be minus 15 there. And there we are then. So we wrote it in that form. We found the missing values a and b and c. And so there we are. Cool. So yeah, that is polynomial division, right? Hopefully these examples have helped. With the main idea again, even though there might be some, if you're a bit confused perhaps with the stuff we looked at the start, some of it, you don't really need to know any of this. You need to be able to spot a top-heavy algebraic fraction, which then allows you to then do division. But you don't need to worry about the division theorem and stuff like this. It just helps you to visualize what the method is doing. It chucks out a quotient, which is g of x, and it chucks out a remainder at the end. And that's all this division is saying. This division theorem is saying, it's just tying it all together, right? in that way. But that's what's going on. That's what the method, the bus stop division thingy is giving us. But you don't have to learn that. The main idea from this is you need to have to perform algebraic division, right, using this sort of bus stop method, which or also called long division. If you can do that, then that's great. Hopefully these examples have helped to first and foremost just be able to carry out a polynomial division, right? Hopefully these examples have helped, and again, I do advise you try and do some yourself. Perhaps do the examples I did, pause the video and try it yourself, and then see you get it right, and then you try and get the hang of the method, and then you master it. But yeah, so that's long division, polynomial division, also there's loads of different names for it, but it's just divided polynomials, right? But I'll see you next time.